Hi, I'm Krishna. This is day 4 of 30 days of understanding the modern AI stack. So, in this video, we're talking about the most important part of the entire learning system, the loss function. If you misunderstand this one thing, your model will learn the wrong thing, get confident at the wrong thing, and fail in the real world. So, what is a loss function? Imagine telling someone to shoot a target, but never telling them what counts as a hit. They might shoot the wall and still think they are doing great. The loss function is the rule that tells the model this is what I want, this is how wrong you are, and fix this. Backpropagation and optimizes only move weights based on that one number, the loss. So if you pick the wrong loss, you train the wrong brain. It doesn't matter how powerful your model is. If your loss is mismatched to the task, it will optimize the wrong behavior. Loss is definition of success. It decides what the model learns to do. So there are two main families of losses. A, regression losses, used when you predict a number like price, rating, temperature. B, classification losses, used when you predict a class or multiple labels. So let's talk about some of the most commonly used regression losses. First one is MSE, mean squared error. Analyzes big mistakes heavily, smooth gradients, easy to optimize. Good when you want accuracy in continuous values. MAE, mean absolute error, punishes all errors equally, more robust to outliers, slower than MSE. Third one is Hubble loss, mix of MSE and MAE, stable with outliers, often used in reinforcement learning. Now, some of the classification losses. First one is cross entropy loss, the king, used for almost every modern classification task. Model outputs logits, softmax converts them to probabilities. Cross entropy measures how far predictions are from the correct class. Why cross entropy works? Because it rewards confident correct answers, punishes confident wrong answers, perfect for multi-class problems. Second, BCE with Logit's laws, binary and multi-label. It is used when task has two classes or multiple labels can be true at once. Multi-level classification. It combines sigmoid and binary cross entropy into one stable function. Third, focal loss for imbalance. If the data set is imbalanced, 99% negative, 1% positive, focal loss tells the model stop focusing on easy negative samples, focus on the hard ones. Used in object detection. RetinaNet is one of the examples where it is used. Now there are advanced losses too. These are not needed every day, but it's good to be aware of them. The first one is contrastive triplet loss, used when the goal is to bring similar things closer and push different things apart. Example, face recognition or embeddings. Second, KL divergence, used to compare one distribution to another. Example, model distillation and VAEs, variational autoencoders. Third, label smoothing, prevents the model from becoming overly confident, improves calibration. So that's all we need at this level. Now the question comes how to choose the right loss. Here's the simplest possible rule set. If you predict a number, MSE or ME, to predict one class, cross entropy loss. To predict multiple labels, BC with Logit's laws. If classes are imbalanced, focal loss. If working with embeddings, triplet, yeah, contrastive. If comparing probability distributions, KL divergence. And remember, your loss must match your task. Wrong loss, wrong model. No matter how fancy your architecture is. Transformers, CNNs, RNNs, the loss function decides what the model learns. If MSE screams, get numeric closeness, and cross entropy screams, predict the correct class. Your model will obey whichever one you choose. This is why choosing your loss is a design decision, not a formality. So that's loss functions, the bullseye of machine learn. Pick the right loss and your model learns exactly what you want. Pick the wrong one and well, you train a disaster. So see you in the next video. Let's do it.